5.1 is the unit circle. The unit circle is a circle with its center at the origin and with radius 1. It takes on the equation x squared plus y squared equals 1. So any radius coming from the origin will be length 1, so therefore it passes through the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We are going to show that the point root 3 over 3, root 2 over root 3 is on the unit circle. So this is our x, this is our y. We are plugging them into the equation x squared plus y squared equals 1. So we're seeing, does root 3 over 3 squared plus root 2 over root 3 squared, does it equal 1? We want it to. So rules on exponents, we got to square the top and square the bottom. Root 3 squared, that just goes to 3. 3 squared is 9. Root 2 squared goes to 2. Root 3 squared is 3. Does it equal 1? Well, convert it to a common denominator. 3 over 9 plus 6 over 9 is 1. So yes, the point root 3 over 3, root 2 over root 3 is on the unit circle. We're now checking the point root 3 over 2 comma y, and we're being told it's on the unit circle in quadrant 4. So we need to find its y coordinate. So let's just think about a circle and its points. We know this quadrant 1, is a positive and a positive. This is a positive and, a negative and a positive for quadrant 2. Quadrant 3, they are both negatives. And quadrant 4, your x is positive while your y is negative. We will need this at the end. So we plug in our points to x squared plus y squared equals 1. We're being told it is on the unit circle. So root 3 over 2 plus y squared equals 1. Square the root 3 over 2. Root 3 squared is 3. 2 squared is 4. Plus y squared equals 1. So we have to subtract the 3/4 from both sides, get y squared equals 1 minus 3/4. So that's 1/4. So if y squared equals 1/4, take the square root of both sides, get y alone. Y is the positive or the negative, and square root of 1 is 1, square root of 4 is 2, so 1/2. And since it's in quadrant 4, we need y to be negative. So it's in quadrant 4, therefore y is negative 1/2. So looking at the full unit circle, we have what's called terminal points, and that's just points that are on the unit circle. So with our radius always being 1, our circumference, using the formula 2 pi r, r is 1, so it just goes to 2 pi. The distance around the circle is 2 pi. We're going to always start at 1, 0. Now that distance around the circle is notated by the letter T for terminal points. It's opposite of what you would think. When you go counterclockwise, it's positive. When you go counterclockwise, when you go clockwise, it's negative. When you go counterclockwise, it's positive. So if we wanted to go a distance of 2 pi, we're at 1, 0. We're going around. We're halfway there. 3/4 the way there. And now we are back. We ended up at the terminal point (1, 0). What if we only wanted to go halfway around the circle? So that would make t just to be pi. We're at 1, 0. We're going halfway around, and we stop at -1, 0. So let's take half of the half. So pi over 2. That's really only a quarter of the circle. We're starting at 1, 0. We go a quarter of the circle and end at 0, 1. Let's go in the negative direction. Let's go a negative pi over 2. So for negative pi over 2, we are now going clockwise. And that's really only a quarter, so we end up at 0, -1. So for negative, it was negative pi over 2. If we had gone the positive direction, we went 1/4, we went 2/4, we went 3/4 to get to that spot. So we did 3/4 of 2 pi. Put it over 1, goes to 6 pi over 4, which reduces down to, 3 pi over 2. So negative pi over 2 is the same as the positive 3 pi over 2. You can also go, perhaps, 6 pi, if t was 6 pi. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. We ended back up at the terminal point of 1, 0. So we can take out multiples of 2 pi. Now these t values measure a distance around the circle, and it's actually in a unit called radians. Radians has to do with pi value on a unit circle. So this will come into play later in chapter 6, but it's good to get introduced to the vocabulary now.